Hello everyone. In today's Z transform lecture, we are going to study some methods of finding inverse Z transform. So what are that methods? Let's see. Here first we will define inverse Z transform again. Inverse Z transform. Operation of obtaining sequence f of n from Z transform f of z is known as inverse Z transform and is defined as Z inverse of f of z is equal to f of n. This Z inverse is called as inverse Z transform operator. F of z, it is the Z transform of the sequence f of n. Therefore, its inverse is nothing but original sequence f of n. There are three methods which we are going to study, and they are: first one is power series method, second one is partial fraction method, and third one is inversion integral method. In this lecture we are going to see power series method. So let us go to that. Power series method. Suppose we have been given Z transform which is f of z, and we want to find inverse Z transform of this f of z. We are going to follow the following steps. In that, first step is, now whatever the region of convergence is given to us, depending upon that we are supposed to take a suitable factor common from the denominator. Means what? Let us see a few examples. First example, suppose f of z is equal to 1 upon z minus a and the region of convergence is mod z strictly less than a. In this first step, we are always supposed to express the region of convergence into strictly less than 1 form, isn't it? Now, to express this region of convergence in strictly less than 1 form, we need to divide by a on both the sides, and therefore our region of convergence, it will becomes now mod of z upon a strictly less than 1. So depending upon this form, what we are supposed to do? We have to express f of z in the form where the term will be z upon a, and to get this form in the f of z, we need to take a common so that a will be in the denominator of z and we will be getting term z upon a. So if we take a common, our f of z, it becomes 1 upon a into z minus a minus 1. So this is in case of the region of convergence mod z strictly less than a. For the same f of z, if we consider region of convergence as mod z strictly greater than a, then to express it into less than 1 form, we need to divide on both sides by mod z, and that will gives us mod of a upon z strictly less than 1, which is the required thing. Now depending upon this, we have to decide what term should we take common, either z or a, so that we will get term a upon z in f of z, in the denominator of f of z. So obviously here we need to take z common so that we will be getting a upon z term in the denominator, and hence f of z, it becomes 1 upon z into 1 minus a upon z. In the second step, we will express the denominator of f of z in the form 1 minus r, where r is the common ratio and it is such that mod of r is strictly less than 1. So whatever examples we have considered in last slide, in the first example, to express the denominator in the 1 minus r form, we need to take minus 1 common so that f of z will be 1 upon minus a into 1 minus z upon a, whereas and mod of z upon a is strictly less than 1. So our r is z upon a in this case, whereas in the second example it is as it is because already there we got denominator in the form 1 minus r. So f of z is equal to 1 upon z into 1 minus a upon z for mod of a upon z strictly less than 1. So this a upon z is the common ratio. Now in the third step, we are going to apply the binomial theorem to this f of z when we express it into the form 1 minus r, and in that we are going to use the formulae for 1 upon 1 minus r, which is given by 1 plus r square plus r cube plus so on, and 1 upon 1 plus r, which is given by 1 minus r plus r square minus r cube plus so on. Okay, once we use the binomial theorem to the or apply the binomial theorem to the f of z, then then inverse z transform is nothing but what? Inverse z transform is the sequence f of n, and that sequence, general term of the sequence f of n will be obtained by or it is given by the coefficient of z raised to minus n in the binomial expansion of f of z. So see, f of n is nothing but what? Coefficient of z raised to minus n in the binomial expansion of f of z, and this is nothing but power series method. I hope you have got this. Now we are going to solve examples based on this power series method. Okay, we are going to see one example. Consider the first example. Find inverse z transform of z upon z minus 2 for the given region of convergence, which is mod of z strictly greater than 2. Solution. So our first step is what? First of all, we will express our region of convergence into strictly less than 1 form, for which here what we need to do? We need to divide by mod of z on both the sides so that it will become of the type strictly less than 1. So that will give us mod of 2 upon z strictly less than 1 when we divide this region of convergence on both the sides by mod z. Once we get this mod of 2 upon z strictly less than 1, then we have to express our f of z in 2 upon z form, for which we will have to take z common. So we take z common from the denominator, and that will give us z divided by z into 1 minus 2 upon z. This z will get cancelled and we left with 1 upon 1 minus 2 upon z. So which is of the type 1 upon 1 minus r. Now in the theory part, whatever formula we have discussed for 1 upon 1 minus r or the binomial expansion of 1 upon 1 minus r, use that and we will be getting expansion for f of z as 1 plus 2 upon z plus 2 upon z bracket square plus so on 2 upon z raised to n plus so on, like this. And therefore we can rewrite this as 1 plus 2 into z inverse plus 2 square into z raised to minus 2 plus so on 2 raised to n into z raised to minus n plus so on. So if we compare this, we will be getting the coefficient of z raised to minus n as 2 raised to n for n greater equal 0, because it is starting with the constant number, isn't it? And therefore we have to consider our n starting from 0. So this way we got coefficient of z raised to minus n, and therefore sequence f of n or the inverse z transform of f of z is equal to 2 raised to n for n greater equal 0. So this is the power series method. We'll consider another example. Find inverse z transform of f of z, which is z upon z minus 3, and the region of convergence is mod z strictly less than 3. Solution. Region of convergence is mod z strictly less than 3. So what is our first step? We have to express this region of convergence in strictly less than 1 form, for which we need to divide by 3 on both the sides. That will give us mod of z by 3 strictly less than 1. Now, to get this z by 3 term in the f of z, we need to take 3 common, and to express the denominator in the form 1 minus r, we need to take minus 3 common. Therefore, f of z will be z divided by, see here we have taken minus 3 common, so denominator it becomes 1 minus z upon 3. Further, this f of z is equal to minus z by 3 into 1 upon 1 minus z upon 3. Now, to this term 1 upon 1 minus z upon 3, it is of the type 1 upon 1 minus r. So, use the binomial expansion to that term and expand it. So, applying binomial expansion, we will be getting expansion of f of z as minus z by 3 as it is, then expansion for 1 upon 1 minus z by 3 will be 1 plus z upon 3 plus z upon 3 bracket square plus so on, and then we multiply by this z by 3 inside the bracket, and that will give us minus sign we have kept outside, so that will give us minus z by 3 plus z by 3 bracket square plus so on, z by 3 bracket raised to n plus so on. So here we will be having the term z by 3 raised to n. From this we will be getting coefficient of z raised to n is equal to this minus sign minus 3 raised to minus n for n strictly greater than 0, because as there is no constant term, so n is starting from 1, therefore here we have considered n strictly greater than 0. But to get the sequence f of n or the inverse Z transform, as per our theory, we are expecting coefficient of z raised to minus n. Here we got coefficient of z raised to n. Therefore, we replace n by minus n, and that will give us coefficient of z raised to minus n is equal to minus 3 raised to n, and n strictly less than 0, which is the inverse Z transform. So, inverse Z transform of the given f of z is equal to minus 3 raised to n for n strictly less than 0. So, this is the power series method. Okay, I hope you have got this. For our reference, here I have given a table of inverse Z transforms. So some useful inverse Z transforms that we will require in the further lecture. So this one is the table which we can easily obtain from Z transforms inverting Z transform formulae. So these are few standard functions f of z whose inverse Z transform is given in this table. So you can refer this for the further lectures. I hope you have got this. Thanks for watching this video.